everyone, welcome back to our channel, The Absolute Chemistry. I am Abhisek. Today we are going to study a very important topic of chemical kinetics. As we all know that chemical kinetics is a very important topic in exam point of view because a lot of questions come from this. Definitely you will get some questions, and also whatever questions come, they are mostly based on formulas, and some graphical questions will be coming. So if you understand a little bit and you know those formulas, you can easily do this. So it's a very important topic, and this particular topic, Arrhenius equation, it's a very important topic because you will definitely get some questions. There is a high probability of getting a question because um, calculation of rate constant, all that is also another point. But how the rate constant is affected by the temperature. When we change the temperature, how the rate constant is changed. It's a very important topic as well. And this relation which I have already written, and some modifications. There are three forms you have to remember. There are actually two forms, this one and another one. You just have to remember two forms. If you remember this one also, you can derive the other one. It's a very simple derivation, you can do it. But there is a high possibility that you will get a question from here. So today we are going to only discuss those formulas because the derivation part is not in our syllabus. So we are not going to discuss about the derivation part. We will only discuss about the formula, and we will discuss some numericals based on this. There are some few previous year numericals which I will discuss. So let's start. I have already written, to save some time, I have already written this one. This equation, I haven't written anything else. So what is actually Arrhenius equation? We all know about rate of reaction, okay, and the rate constant of a reaction. We all know how to write. See, I am assuming that we know that. Okay, if you don't know, I'll definitely make some videos on that. You can refer that also. But now I'm assuming that you know how to determine a rate of reaction, how to write a rate equation or rate law expression. All these things you should know. Okay, so now we will see how the effect of temperature, that if we change the temperature, how the rate of reaction is affected. See, we all know that how a reaction takes place. Okay, reaction only the reaction will happen, or the reaction will occur when there will be some effective collision between the reactant molecule. Now, what is that effective collision? I'm only briefing about it. I won't go into very detail. Okay, what is collision? What is that effective collision? Because see, suppose there are two reactants. Okay, there are two reactants. They have some kind of vibrational energy or kinetic energy, anything, some kind of energy they possess. So due to that kinetic energy, they will have some velocity. Okay, they will definitely have some velocity. So when they will collide with each other, effectively, I'm saying effectively, we are using the term effective collision. What is that effective collision? Effective collision means there is a concept of activation energy. Okay, whenever you want to achieve a whenever you want to proceed with a reaction, those reactant molecules definitely have to overcome that activation energy barrier. This concept is actually we study in Arrhenius theory. Okay, but today I'm not really concerned about the theory, so I'm not going to go deep into it. But while solving the questions, I'll definitely, because I have selected some questions intentionally. I have selected some questions where your concepts will be little bit clarified. Okay, so we will definitely do that, but I'm not going to enter into that conceptual point in this video. Okay, so now let's talk about this particular equation. Okay, as you can already see, I have written that k equal to a into e to the power minus ea upon rt. Now, what is this k? What is this k? K is nothing but it is the rate constant. Okay, it is the rate constant of a reaction. Now, what is that a? This a is the a is known as pre-exponential factor or the frequency factor. Okay, so this is basically a, you can say that it is a proportionality constant. Okay. Now this, what is that R? This R is nothing but this is the ideal gas constant. Okay, this is the ideal gas constant, and see, ideal gas constant have different values in different units. Okay, you know that we have 4 or 5 values for ideal gas constant. You have to know all the values, but in this case we are taking the joule per mole Kelvin value. That is the 8.314. We will apply this one only. Now what is that EA? Sorry, it's not E, it's not EA. EA is nothing but the activation energy. Okay. Now T equal to temperature in Kelvin. Okay. So now we have to remember. See, we have to know another two forms of this equation. This equation you have to by heart because the derivation is not in your syllabus. We are not concerned about the derivation of this particular equation. Okay, but we will have to solve a lot of questions. Okay, by using this, so you have to by heart this equation. You don't have any other choice. But the rest two forms of this equation we can derive it very easily, very easily. Nothing is there. Okay. So let me just erase a little bit. Okay. I want to erase. I need some space, so I'm just erasing a little. I hope it's fine. If you want to write it, you can just prepone the video and you can see it. Okay. You can pause it and you can write. See, I'm taking ln of both side. Okay, if I'm taking ln of both side, what will happen? So it will be ln a minus ea upon rt. Okay, how is this happening? Do you know a simple mathematics how the logarithm works? It will happen because when you take ln of this one into e to the power minus a upon rt, what will happen? This will be ln a plus ln e to the power minus ea upon rt. Okay, and we know that this ln is nothing but log base e. So if we replace it with log base e, let's replace log base e ea upon rt. So we all know that if logarithm of a base a is there, a to the power x is there, so it is nothing but x. It is nothing but x. So now, simple. So now we just have to apply this formula, and what will happen? Where is the eraser? Uh, yeah, alright. So Microsoft is not launching the updated version of this whiteboard, which I really need it. What is happening? Just give me a second. Sorry for the disturbance. So now what will happen? So if you now, according to that formula, so what will happen? This will be ln a minus ea upon rt because this is the x. Okay, this is the x. Alright. So now ln k is equal to nothing but ln a minus ea upon rt. Now let's do a little more modification. Okay. I am erasing it because I have already written it there. So what can we do now? Suppose we are taking this equation at two different temperatures T1 and T2. Alright. So in T1, suppose the rate constant equal to K1. Suppose the rate constant is K1 and at T2 the rate constant is K2. So if you put it in this equation, what will happen? ln K1 will be ln A because exponential factor that is constant for a reaction. Okay, irrespective of the temperature, that is constant for a reaction. Just give me a second. Sorry, that is constant for a reaction, and activation is energy is also constant for a reaction. Ideal gas constant is also constant for everything. This T, according to the T1, it will be T1, and let me take at temperature T2. So ln K2 will be again ln A, because A will be a constant, EA is constant for reaction, R is constant for everyone, and the temperature is not constant. Okay, let's do ln K2 minus ln K1. Okay, so what will happen, these two terms, they will be cancelled out. You know that they will be cancelled out because ln K, let me write. So it will be ln A minus EA upon RT2, this is one form, minus ln A minus EA upon RT1. Okay, what will happen now? If you open the bracket, what will happen? This ln A will be cancelled out. So now what will happen? EA upon RT1 minus EA upon RT2, because this negative charge, this negative sign and this negative sign will be positive. So it will be like this. Okay. So what happens? So now this ln K2 minus ln K1 will be equal to EA upon RT1 minus EA upon RT2. Alright, and we all know that this is nothing but ln K2 by ln K2 by K1. And what will happen? EA upon R will be constant, so this will be 1 by T1 minus 1 by T2. If you simplify it further, it will be EA upon R T2 minus T1 upon T1 T2. You know now, T2 minus T1 upon T1 T2. You are taking the LCM. Okay. So there are three forms we have got for this Arrhenius equation, which you have to know. The first one I have already written in the first. I have written it at number 1. Then the second one also I have written. Now the third one. So what was the third one? ln K2 upon ln K1 is equal to EA upon R T2 minus T1 T1 T2. Okay. You can do also one thing, log K2 up, you can do it in the form of log also. So you have to divide 2.303. Okay, everything else will be similar. So these equations you have to remember. There is no other choice. This one you must remember, this one you can derive. Okay, it's a very simple derivation, but you should remember this one, because question will come. Most of the questions are going to come by using this equation. Actually, this equation, you will be needing this equation, logarithm equation. Okay, so you have to remember this equation. Okay, so now the concept part is over. I have nothing more to say. I only do one thing. I'll just draw some graphs. I'll only draw two graphs. Then we will jump to the questions. Directly we will jump to the questions. Okay, so let me just draw the graphs here only. Why not here? Yeah, the first graph is by using this equation. Okay, by using this equation, K versus T. Okay, K versus T. This is nothing but the graph will be like exponential increase. Okay, exponential increase. This graph is not that important for you. The next graph is very important for you. I'm just erasing this one a little bit. Okay, you have, if you want to write, you can just pause the video and you can write it. Okay, yeah, I need some space. Now let's see this equation. If I'm taking it in y-axis and I'm taking this 1 by t. Okay, let me just erase it again and write it in a little bit different way. EA upon R into 1 by t. Okay, so if this is my x, so this will be my m. Let me put a positive sign and let me put a negative sign here. Okay, positive, negative, negative. So I'm just taking negative inside this. So this is the slope and this is the intersection. Okay, so the shape of the graph is nothing but like this. In y-axis you are taking ln k, and in x-axis you are taking 1 by t. Intercept is lna. This is the lna intercept, and the slope is negative, that is minus ea upon r. So the slope for this graph is minus ea upon r. This graph is very important. This graph is very important. And again, another thing I would like to say. See, this video is kind of a revision type video. Okay, so I'm making it a little fast. Okay, what you have to know, that only I am going to discuss. Okay, I'm not going to elaborate it very much. Okay, if there are two graphs like this, if there are 2 points like this, okay, let me just draw it like this. Suppose this one is the first graph, this one is the second graph. Okay, you know the slope of 2 is more than 1. The slope of 2 is more than 1. If you don't know, then let me just put it this way. Just imagine. Okay, just imagine. Don't imagine like this. Yeah. Suppose I am taking till that intercept. Okay. What is slope? Slope is nothing but delta y upon delta x, isn't it? Okay. So for graph 2, for this line, second line, this is the delta y and this is the delta x. And for graph 1, this much is the delta y, this much is delta y, this much, and this much is delta x. Delta x is same, the denominator is same. The numerator is more, slope is more, so slope of 2 is more than 1. Okay, the slope of 2 is more than 1. So now what shall I say? So the activation energy of 2 will be more than activation energy of 1. So you have to remember one point here only. You have to remember one point that I am writing here. Okay, what you have to remember is more the slope or higher the slope, higher is the activation energy. Okay, higher is the activation energy. Uh, so this much only you have to know for this Arrhenius equation, and we are going to solve some questions. Okay, this is the part 1. I am going to make a part 2 video just after this. Okay, so because now I'm trying to split them to make it small videos. Okay, so I hope you like this video. If you like, then please like the video, share it with your friends, and thank you for watching.